Welcome!
Hi, welcome to First Saturday Science. This is March 2022, and this month we're studying space. So today we're going to do a few experiments. This one in particular is going to be on black holes. If you don't know what a black hole is kind of like how it sounds. It's like this hole in space. And the gravity inside of this hole is so strong that light can't escape it, which is what gives it that notable black hole appearance on photographs of space. And black holes have a reputation for being kind of a scary thing a little bit sometimes because they have such a strong pull that they kind of suck everything into it. But that only occurs when it's when whatever spaceship you might be considering getting sucked into the black hole is actually pretty close to the black hole, because it's pretty small on the relative scale of things. Black holes start as stars, so all the stars that you see in the sky have, in theory, the potential to become black holes. But something very specific has to happen to it, right? The star has to burn out first, and then the star has to become very, very compressed. So when something is compressed, it starts out really big, and then it becomes very, very, very small. And the force of a black hole is dictated by the amount of energy in the small space. So if you have a lot of energy in a small space, it's going to be really, really strong. And that's where it gets that signature force of pull, where it wants to kind of pull things into it or towards it. And today we're going to do an experiment. Obviously, we're not going to make a real black hole, but we're going to use balloons to represent stars. And we're going to show you a little bit about how that black hole kind of comes to be based on the specific parameters that it might be under. So here we have our materials, and today we're going to be using some balloons, and we're going to use a balloon pump to pump up the balloons, and we're going to use a pen to pop our balloons and some tin foil. So if you want to get those materials ready, you can pause the video and grab them. Right now we're going to get started, and I like how shiny these little white ones are, so we're going to use these ones. And tie off the end. There's one balloon. I'm going to set this aside for just a second. One more. Now that we don't need our balloon pump, I'm going to put it to the side and show you my 3 pumped balloons. And these are going to represent our stars. So stars will have a set amount of pressure in their system that kind of gives it this mass, just like balloons. They stay full because it's filled with air. And so the air is going to kind of act like our pressure system, keeping our stars large. And next,
You want to make sure to grab some aluminum foil, tear off a big enough piece, place it down on your table, place all of your balloons on top of this aluminum foil, and create kind of like a boat so that they don't roll away or float away. After you successfully created kind of this boat thing, you want to make sure that you grab another piece of aluminum foil, place that aluminum foil on top, almost like a sandwich, and you want to make sure that you are squishing it in so that it is covering really well all of your balloons. And if that didn't go very well, then you can always grab another sheet of aluminum foil, a little bit longer this time, and place it right over. Make sure that you get that form of the balloons really well because we're going to pop them in the next step. So this is what it should look like here.
Okay, and now you can kind of see this big shiny mass, and this represents our star floating around in space. And this is kind of, I mean, you can kind of feel it, right? If I push on it, nothing really, it kind of moves a little bit, but it doesn't compress. When you push on it, it kind of stays in its big mass, right? Kind of like the star shape that it has, just like a real star. Because the stars have this constant force of fusion and pressure in its system that gives it its full mass. And so what we're going to do now is we're going to see what happens when it no longer has that force working upon it. So I'm going to take my pen, which has a nice little pointy end, and I'm going to pop the balloons. It could be a little bit loud, so just a warning. Now you can see the balloons are popped, I'm sure you heard. But we still kind of have this big mass, right? So this is kind of what happens when that force of pressure is released in a star. Now what happens when it compresses? Now I'm going to have you squish your tinfoil up into a really tiny little ball because all that pressure is no longer gone, and so the force working upon it is actually going to push this all into itself. And now we have our black hole. So this is how black holes are formed. It starts out with this large star mass, and it compresses into this tiny little point in space. And it has a lot of energy still. And it has a huge gravitational force. So anything that's going to enter its vicinity in space, it has to be pretty close, kind of like we discussed a little bit in our intro, where something will come close to it, and then it'll be pulled in because it has so much force in such a small amount of space. Thank you.